Welcome to lesson 3, focusing on the chemical bond. Okay, so this is going to be again a bit of a review from grade 9 and grade 10, but we're going to try and review first and expand on it later. So if you remember, looking back at your periodic table, and again this is from ptable.com, which we're going to use a lot this year, you're looking at these atoms present here on the periodic table as neutral atoms. They all have the same number of protons and electrons, but they're not all happy. Again, that goal for all these atoms is to have that stable valence electron shell. So the outer shell of electrons, they want that to be full because energetically that's preferable. So for example, something on the left-hand side like lithium or sodium has that one valence electron. It's trying to get rid of it. Okay, and on the right-hand side here, something like fluorine has those 7. It wants to gain electron. It wants to have that full shell. So something that the electrons do to help with that is bond. So they're either going to give and take electrons, or they're going to share electrons between atoms. So first, let's just look at oxidation number and oxidation state and what that means. So oxidation number, oxidation state really is just a real or apparent charge, can be positive or negative, that an element acquires during the formation of a chemical bond. So either that shift or the transfer of valence electrons between atoms. Okay, so all these elements that we see on the periodic table, they're neutral. They have an oxidation number of 0. Okay, it's not positive, it's not negative, because they have the same number of protons, positive charges, as electrons, negative charges. Okay, so if you have 2 pluses and 2 negatives, 0, an oxidation state of 0. And that's how we show it. Okay, so an oxidation number equals 0, as no electron sharing or transfer has occurred. Now, if some electron sharing or transfer has occurred, now we have charges on these ions. And we write it, as you can see here, with the symbol of the element, and then the charge up with the right, with the number first and the charge second. Okay? Now, the oxidation numbers themselves are written as sign, then number. So the oxidation number for Cu2 plus is written as +2, where the charge on the Cu2 plus is 2 plus. Okay, so when it's written with the symbol, we put the number and then the charge. When we're dealing with just the oxidation number itself, it's a +2 oxidation number. Okay, so this is kind of semantics, things that are important, even though they may not seem important. Okay, so now let's start by looking at ionic compounds. Okay, and so if you think back, if you remember, you're dealing with metals and nonmetals when we talk about an ionic bond. Okay, and I'm going to work through some of this ionic bonding tutorial, which you can find in your lesson 3 note, and work through it yourself if you would like. So again, an ionic compound uses something from an atom from the left-hand side of the periodic table, one of these metals, and that reacts with a non-metal here from the right-hand side. So ionic bonding, to sort of understand it, we need to understand charges first. And so if you think back to thinking about charges and what you know about magnets and charges, things like that, what do you suspect will happen in this case here when I put these 2 negative charges, they're the same charge, close together? So I want you to answer the question on that on your Edpuzzle first. Okay, so now that you've done that prediction, let's see what we expect to happen. So I will bring the negative charges together, and now you can see that they are repulsed by each other, right? They repel each other. They do not want to be near each other. Okay, so a negative charge repels another negative charge. Similarly, a positive charge would repel another positive charge. So like charges repel. Okay, now what happens when 2 opposite charges come in close contact to each other? So a positive and a negative, and you can already see the attraction that created. Okay, and there's a high level of attraction between these opposite charges, the opposite of 2 like charges. And this becomes important now in dealing with an ionic bond. Okay, we're going to create 2 opposite charges, and there's going to be a large attraction between the 2. Okay, so again, atoms on the left-hand side of the periodic table are going to form those positive ions. Generally, those are metals. And on the right-hand side, you're dealing with these non-metals. They're going to form the negative ions. So let's take a specific example here of table salt, sodium chloride. Sodium has 1 valence electron. Chlorine has 7. So what sodium does is it gives up its one valence electron to get a full valence shell, and chlorine takes one on to fill its octet to get 8. What that does though is it creates a very strong positive charge on the sodium, as it now has one more proton than electrons, and chlorine now has one extra electron than protons, so it becomes a negative charge. And what we saw before is that attraction between a positive and a negative charge. That's an ionic bond in a nutshell. Okay, an electron is transferred, and then there's that high degree of attraction between the positive and the negative charge. Okay, now in reality, you're not dealing with one sodium and one chlorine. Okay, generally chlorine travels in pairs, so you'd need a second sodium to take away the other chlorine molecule, or atom, sorry. Now again, this isn't so much reality as, again, this is happening at a very, very tiny level. And so think of a table of shaker salt, or a salt shaker. Okay, you've got millions and millions of these atoms and these molecules inside. And so what actually happens in that salt shaker is we see a crystal lattice formed. So a three-dimensional shape with chlorine atoms connecting sodium atoms, creating this three-dimensional structure that you see here. And this is, any ionic compound is going to form a lattice like this. Now in this case we have a 1-to-1 ratio, okay, of 1 chlorine for every 1 sodium, and that's why we have NaCl. In some cases you'll have a 2-to-1 ratio where you may have 2 chlorines for every 1 calcium, for example. Okay? And in that case you would have a different structure. It wouldn't be quite as uniform as this, but it would still form this crystal lattice. Okay? So what happens now if we have 2 nonmetals? You still want to form these happy molecules, or these happy atoms, but now we can't give and take electrons. There's too many electrons present. There's not one atom, for example, carbon doesn't want to give up all 4 of its atoms. Okay? So what these atoms will do is they'll share electrons. Okay? And let's take a closer look at what this looks like, a covalent bond sharing of electrons. So in this case, this example here, I have 2 hydrogen atoms. You can see the blue in the center is the proton, or the nucleus, and around you have your negative electron orbiting that nucleus. As I bring these 2 together, you start to see the electron of the right-hand proton, or that's circling the right-hand proton, get pulled more to the middle, because now you're getting the attraction from the other proton. And so now these 2 protons are, as much as they don't want to be together, their electrons are holding them together, because there's now an attraction between each electron as well as the proton. Let's take a closer look at what that should look like. Okay, so now we're gonna put a pink line in there to help, and as I bring these 2 together, you see now a stronger interaction. You can see now that there's almost this electron from the right-hand proton is now also attracted to the left-hand proton. Okay. Similarly, the electron from the left-hand proton is also attracted to the right. And so there's an equal attraction there. Okay, they're both now fighting for these electrons. And this creates that bond. It's not so much a sharing almost as it's a fight between the 2. And that fight creates what we call a covalent bond. So we're going to go into more depth as the unit continues, but again, it's the importance here is that sharing of electrons. Both protons want the negative charge from the other one, and the electrons don't know where to go. They're getting pulled from both sides, again, because of that negative and that positive charge being attracted. Okay, we'll see you in class.